In this video, we're going to be adding and subtracting radicals. Now, in order to be able to add and subtract radicals, we have to have the same exact radicand. So remember, the radicand is the value that's on the inside of the radical symbol, and then it has to have the same exact index. They have to have the same exact index. So these are all square roots. So this would qualify. So we have 2 times the square root of 3 plus 4 times the square root of 3 minus, this is another way to say 1 times the square root of 3. So if there's not a number out there, we can always put a 1. Now when adding and subtracting, like radicals, the radicand is going to stay the same, but you are going to combine the coefficients. And the coefficients are going to be the outside number. So in this example, we have 2 times the square root of 3 plus 4 times the square root of 3 minus 1 times the square root of 3. Well, this would be 6 times the square root of 3. And then if we take away 1, that would be 5 times the square root of 3. So our answer, technically, we took 2 plus 4 minus 1, and then we kept that square root of 3. And that's how we get 5 times the square root of 3. It's very much like adding and subtracting like terms. Okay, let's try another one here. Now, most of the time, you'll need to simplify each radical first. So I've got the square root of 45 minus the square root of 80. These are both square roots. So these are both square roots. However, this time the radicands are different. Now when the radicands are different, we're going to have to try and break them down first. So we're going to break down a 45. 3 goes into 45 15 times. 3 goes into 15 5 times. So the first term is going to break down to be 3 on the outside times the square root of 5. The second term, we're going to break down that 80. 2 goes into 80 40 times. 2 goes into 40 20 times. 2 goes into 20 10 times. And 2 goes into 10 5 times. So we have a pair of 2's, another pair of 2's. That's going to be 2 times 2 on the outside, so that's minus 4, times the square root of 5. So now we have 3 times the square root of 5 minus 4 times the square root of 5, which is going to give us a negative 1 times the square root of 5. Now, we can write it negative 1 times the square root of 5, or we can just write negative square root of 5. Either one of those is correct. The second one is probably the one that will be most common. So I'm going to put a little heart around that one. That's going to be the one that is probably the way you would see it in a textbook or on an answer key. Okay, let's try another one. We've got 3 times the square root of 75 minus 2 times the square root of 48. Now again, I have the square root for both of them, so they have the same index, but now we have to take those radicands and see if we can break it down and end up with the same leftovers inside. So we're going to say 3 goes into 75 25 times, and then 5 goes into 25 5 times. So I'm going to take a pair of 5s. One of those 5s is going to go to the outside with the existing 3. So we'll have 5 times 3 times the square root of 3 minus, I'm going to break down this 48. So 48, 2 goes into 48 24 times. 2 goes into 24 12 times. 2 goes into 12 6 times. 2 goes into 6 3 times. I've got a pair of 2's once, twice. So I'm going to take 1 from each of those, multiplied on the outside, the existing 2 that's already on the outside, and then I'm going to have a square root of, and I'm going to do this in a blue, this 3 is left over, that goes inside. So we have 15 times the square root of 3 minus 2 times 2 times 2 is 8 times the square root of 3. 15 minus 8 is 7 times the square root of 3. Now we can do this when there's an index that's not a 2. It doesn't have to be square roots. In this example, we've got cube roots. So we're going to see that we have a cubed root and a cubed root. So now we're just going to break down each radical. So we'll have 32. 2 goes into 32 16 times. 2 goes into 16 8 times. 2 goes into 8 4 times. And 2 goes into 4 2 times. That would be 5 2s. I need groups of 3. So we're going to take one of those 2s to the outside. And then I've got 2 2s left over. 2 times 2 is 4. Plus 1 times the cubed root of 4. And now they have the same exact index, the same exact radicand. So these are like radicals, which means I can simply add or subtract the coefficients depending on what it wants us to do. Here it's 2 plus 1, which is 3 times the cubed root of 4. And now we have one for you to try. So go ahead and try this one. Press pause, and when you're ready to see the answer, come on back. Okay, welcome back. You should have gotten -2 times the cubed root of 3. Now, if you got that, then that's your check your understanding. That means you're right on track. If you don't have that, you definitely need to reach out for some help, and we can get you that help. Okay, in the next video, we will incorporate some variables.